Last week, we spent the entire week talking about the basic 8 identities and how you can use those identities to simplify things, right? We could simplify just some expression. You could simplify one side of an equation to look like another side. But I did have us memorize those basic 8. Okay, we are going to add more identities to that. Today we're going to do sum and difference, but I'm not making you memorize these, okay? But some of us still have not memorized our basic 8. So make sure you have those memorized because it's going to be on our test, and we will take that test before Thanksgiving break, all right? So if you have not memorized those basic 8, get on it, all right? Okay, so here it says that cosine of 50 plus 20 is equivalent to cosine of 70. Everyone agree with that? Mm-hmm. Yeah. Looks like all they did was add those like terms in there, right? 50 plus 20 is 70. They ask, does cosine of 50 plus 20 equal the same thing as cosine of 50 plus cosine of 20? What do y'all think? No, probably not, right? Because this is cosine of 70 degrees, right? Mm-hmm. So let's check. Put cosine of 70 degrees in your calculator. Make sure you're in degree mode. Just type in cosine of 70. What do we get? Okay. So less than 1? Okay. Now I want somebody to type in cosine of 50 plus cosine of 20. So type all that in at once, and let's see what you get there. It's over. So they're not equivalent, right? Okay. So what we need is some way that you can rewrite things, right? So that's what these identities are today. So these are the ways that you can rewrite them that they will be equivalents, okay? So let's say you have sine of some value plus some other value, okay? So it says plus in between them. This would be the identity that I'm allowed to rewrite it as, okay? And it says sine of A times cosine of B plus cosine of A times sine of B, right? Okay? If you have sine where you are subtracting two values, it's the exact same identity, but change that plus in the middle to a minus, okay? If I have cosine of two things being added together, the rule changes a little bit. You're going to write it as cosine of A, cosine of B, so both the first things are cosines, minus, so opposite sign, sine A, sine B, okay? If you have cosine and you are subtracting two terms, it's the exact same formula except that minus becomes a plus. Okay, again, I'm going to give you these so you don't have to have them memorized, but we do need to know how to use them, how to apply them, all right? So we're going to look at some problems where we go from it being written like this and we turn it back into this, and also maybe somewhere it's written this way and I turn it into this, all right? So let's look at example number 1. Example number 1 says we've got cosine of 3x times cosine of 2x plus sine of 3x, sine of 2x. So which rule would you guys say that looks most like from our box up there? The fourth one, right? Because in the fourth one, it has cosine A, cosine B plus sine A, sine B, which is exactly what we have here, right? There's a plus there in the middle. And we got cosine, cosine, sine, sine. Okay, so since it's currently written as the way it's highlighted here, we want to rewrite it this way. All right? So it says we write it just like this. So I should have cosine of A. What was our A value in this equation? So what's where A is? 3x, And then in that parenthesis after A it says minus B. What's B? 2x. Okay. Well, this kind of looks like the one that we looked at the very top up here, where it had 50 plus 20, and we were able to simplify that to cosine of 70. Are these like terms in here? Mm-hmm. Yeah. So I should be able to subtract them, right? Mm-hmm. So what is 3x minus 2x? So this simplifies to cosine of x. Now, do we have any idea what x is? No, they didn't tell us. So I can't simplify any further. That's as far as I can go. But we did simplify it quite a bit, right? It was pretty big. We brought it down to a single term. Okay, we're going to do the same thing on B. For sine of 105 cosine 115 minus cosine 105 sine 15, which rule would you guys say that's most like from our box up there?
Second one.
Second one, okay. All right, so let's rewrite it in that shortened form. So what am I going to have? Sine of 105, Mm-hmm. All right, again, those are like terms in there, so we should be able to subtract. What's that going to give us? 90. Okay, so sine of 90 degrees. Okay, so this is a little bit different than the one before because before it was just x. Here it's 90. We know where 90 degrees would fall on our unit circle. So if I were to draw a little coordinate plane here, where is 90 degrees on that coordinate plane? Right, up here. And what is that coordinate point at that location? Pi halves is 90 degrees in radians, but what's the coordinate point? 0, 1. Okay, where this is x and y, right? And r is always 1. Perfect. Okay, so they asked for sine of 90. Well, sine is the ratio y over r, right? So at 90 degrees, what would our ratio be?
1.
Right. Y is 1, r is 1, 1 over 1 is 1. So I could actually say this is equivalent to 1. So if they tell you what the x is, like this time they told us it was 90, we're able to take it a step further and go ahead and simplify it all the way down. But if we don't know what x is, we can't do that. All right? Okay, so it looks like we could use our sum and difference identities to simplify things that look like this, right? Okay, let's look at number 2. It says number 2 wants us to prove that cosine of pi plus x equals negative cosine of x. Well, that's like what we were doing on our notes and assignments last week, right? Where you make one side look like the other to prove something equals something else. Okay. Well, we've got cosine of pi plus x. Which rule would that be from our table? Or our box up there? 3. Okay. So let's rewrite that piece using that rule. So the third one says that cosine of a plus b, which is what we have here, is equal to cosine of a, what's a? Pi, times cosine of b, what's b? X, minus sine of a, which you guys said was pi, right? Times sine of b, which you said was x, right? And this is all equal to that negative cosine of x over here. Okay. Now, some of these pieces, we should be able to say what they are, right? Just like I know what 90 degrees is, do I know where pi would be? Yeah. So if I were to draw me another little table here, where is pi?
Left.
The left, okay? And where is that coordinate point?
0, 0.
Negative 1, 0. So x and y, right? Where r is always 1. Okay. So first over here, I have cosine of pi. Cosine is x over r, right? So at this point, x over r would be negative 1 over 1, which is negative 1. Okay, so I can replace this with negative 1. But I don't know what x is, right? So I can't change that. That just stays cosine of x. Minus, we've got sine of pi. Well, sine is y over r. So at that point, what would y over r be? 0. So I'm going to replace this with 0. Again, I don't know x, so that has to stay. Sine of x, right? Equals negative cosine of x. Okay, now I just need to simplify. So here I've got negative 1 times cosine, which would just be negative cosine. And here I'll have minus 0 times sine. What's 0 times sine? 0, right? 0 times anything is 0. So that just goes away, right? So we did, in fact, prove that the left side is equivalent to negative cosine of x, right? Okay, so we can use it to simplify, like on number 1. We could use it to rewrite part of our equation to prove that sides are equal. And then let's also look at number 3. This is one other thing that we've done before that this might be helpful for. Okay, so it says, suppose sine of alpha is 4 over 5 and sine of theta is 5 over 13, where alpha is between 0 and 90 and theta is between 90 and 180. And we're supposed to find the value of cosine of alpha plus theta. Okay, so they told us alpha is between 0 and 90, and theta is between 90 and 180. So on a coordinate plane, where would those be located? Which quadrants? 1 and 2. Okay, so I'm going to draw me a little coordinate plane here, but I'm only really needing quadrants 1 and 2, so I'm not going to make my 3 and 4 very big. Okay, so which one is in quadrant 1? Alpha, right? Alpha is the one between 0 and 90, okay? And that was this one right here, okay? And we said the ratio for sine is y over r, right? So this must be the y, and this must be the r. Okay, so then I can draw myself a triangle. And what do I label the side that's y? 4, right? Because y must be 4. And what's r? 5. And remember, r is my hypotenuse, right? So the only piece I don't know is x. Could we find it? Yeah. What would we do? Pythagorean theorem. This one's actually one of our most common Pythagorean triples. Anybody remember what it is? 3. Good.
Great job.
Okay. All right. Okay, now theta, it said, was in quadrant 2, right? Because it was between 90 and 180. So I've got this triangle over here where, again, it was sine. So this is still y and this is still r. So what's y? 5. And what's r? 13. So again, the only one we don't know is x, but you guys said just like last time, we can still find it, right? Yep. What do I have to do? Pythagorean theorem. This one's also a triple. Anybody remember what this one should be?
I don't know what that means.
12, yeah. Okay. All right, so just one more thing we need to consider. If I'm in quadrant 2, are x and y positive there? No, what's negative? The x. So I just need to make that a negative 12. Okay. All right, so now that we have a picture to reference, let's take a look at what they actually asked for. They said to find cosine of alpha plus theta. So which rule is that from our box up there? First, second, third, what? Third. Okay, so we've got, if I rewrite it then, cosine of A, what's our A? Yeah, so what's our A? Alpha. Okay. Times cosine of B, what's our B? Theta. Minus sine of A, again, you guys said A was alpha, times sine of B, and B you guys said was theta. Okay, so hopefully we can simplify some of these things. For example, for this one over here in quadrant 1, we were told that sine of alpha was 4 over 5, right? But once we found the missing x value, you guys should also now be able to tell me what cosine of alpha would be, right? What would cosine of alpha be?
Wait, is that sine of
3 over 5.
is that sine of x or sine of alpha?
Sine of alpha. Okay. All right, and then for quadrant 2 over here, we were told sine of theta was equal to 5 over 13, but now you guys should also be able to tell me what cosine of theta is. What's that? Negative 12 over 13. Perfect. Okay, so now we're just going to substitute this information in. Just like up here, when we knew this information, we were able to plug things in here and here, right? Okay, so what is cosine of alpha? 3/5 times cosine of theta, which is
Negative 12 over 13.
negative 12 over 13, minus sine of alpha, which is 4/5, times sine of theta, which is 5 over 13. So we just took these and plugged them in, right? Okay, so now we would need to simplify. So what am I going to do first? Order of operations. Multiply. I'm multiplying fractions. How do I multiply a fraction?
Are we not using a calculator?
Oh, wait, can we?
You go across.
You go across the top and across the bottom. Is there any kind of an equal sign here?
No.
So would I be allowed to cross multiply?
Nope.
Oh, no.
No.
Wait, do we not get the calculator?
You do. I just wanted to point out that
Just in case.
some of us, I think, forgot some algebra rules.
I did too.
Okay, so like you said, we multiply across the top. 3 times negative 12 would be negative 36. Over in the bottom. Oh, sorry, that says I put a 15 there. I did not mean to do that. That's a 5. I'm sorry about that. 5 times 13 is 65. Okay, minus, I got to do this fraction. 4 times 5 would be 20 over 65. Okay, so after you multiply, that's when I'm allowed to add and subtract. I'm subtracting fractions here. What do we have to subtract fractions? Do we have one?
Yes.
Okay, so we're good there. Okay, so you guys said whenever we multiply fractions, we multiply across. Okay, how do I add or subtract fractions? What am I actually adding and subtracting? Just the top, just the numerator, right? So don't forget, we aren't doing anything to the bottom, just the top. So what is negative 36 minus 20? $56, right? This is negatives minus 20, right? All negatives. All over that 65. All right.